Hello friends, welcome to this third video on two-dimensional random variable continuous case. This video aims to explore all the formulas which we learned about the continuous case using our part 1 video, namely the marginal densities, the conditional value of a given random variable y with respect to x and x with respect to y, the independence condition, how to estimate the probability of any given random variable to a greater than or lesser than quantity, and so on. Okay, we will move on quickly to the problem. The joint PDF of a two-dimensional random variable x and y is given by f of x comma y is x squared plus xy by 3, valid for 0 less than x less than 1 and 0 less than y less than 2. And the function is taking the value 0 elsewhere. We have been asked to find a set of quantities, marginal density function of x and y, conditional density function of x given y. We have been asked to check if x and y are independent. Find the probability of x greater than half, y less than half, y less than half, condition x greater than half, and x plus y is less than or equal to 1. We will try to explore them one by one. So we move on to the first question, namely the marginal density function of x. The marginal density function of x is given by f of x. And formula for f of x, we know that when it is with respect to x, integrate with respect to the opposite variable or the opposite pole, which is going to be dy. So what will happen is we are going to integrate the function. What is the function? X squared plus xy divided by 3 with respect to y. What is going to be the limit of y? Y varies between 0 to 2. So y varies between 0 to 2. I am going to integrate this function with respect to y. With respect to y, the variable x is going to be treated as a constant. So x square y plus x by 3 is a constant. Y on integration is y square divided by 2. Apply the limit between 0 to 2. Now this gives me, to keep in mind that the value taken by is going to be for the variable y, because we need to diminish y. Don't apply it for x. So apply it for the variable to be diminished for. So it is x square into the upper limit minus lower limit 2 minus 0. And the second quantity is x divided by 2 3s are 6. The upper limit is 2 square. Okay, 4 minus 0. So the value taken is 2x square plus x by 6 times of 4. So this can be cancelled off with 2 by 3. So the function f of x, the marginal density function of x, marginal density function of the random variable x, fx is given by 2x square plus 2x divided by 3. And we will have to complete the function by defining its range. The range is for the variable x. What is the range of the variable x? X varies between 0 to 1. So x varies between 0 to 1. This completes marginal density function of x. Now next, moving on to the marginal density function of y. This is going to be integral f of x comma y with respect to dx. So now integrate the function x square plus xy by 3 with respect to the variable x, and we know that the limit of the x is going to be from 0 to 1. So now this gives me x on integration x cubed by 3 plus y by 3 is a constant, x on integration is x square by 2. Apply the limit between 0 to 1. So this gives me 1 by 3 plus y by 2, 3s are 6. And now this variable is going to be 1 minus 0. Okay, so the function f of y is going to take the value 1 by 3 plus y by 6. Now you will have to complete the definition of this function by including the range for the variable. Now the value is going to be entirely in terms of y and the constant, where my y varies between, we know that the limits for y are from 0 to 2. So marginal density function of y is going to be over. Now moving on to the third question, we have it as the conditional probability of x given y. We know that the conditional probability of a given b is defined by the formula probability of a intersection b divided by probability of b. And when it comes to two-dimension random variable, intersection is now replaced by the symbol called as comma. So it becomes your f of x comma y divided by f of y. That's how we arrive at this formula. Now this is quite simple because we already have got the inputs over here. F of x comma y is there in the given question. The question is x square plus xy by 3. So my numerator is got. The denominator is f of y, which we just now found out. The value for my f of y is 1 by 3 plus y by 6. So substitute it over here, 1 by 3 plus y divided by 6. So my f of x restricted to y, or conditional probability of x given y, is x square plus xy by 3 divided by 1 by 3 plus y by 6. We can notice that this function involves both the variables x and y. Therefore, to complete the function by specifying the limits for both the variables x as well as y. So now this completely defines the conditional probability of x given y. The next question we were asked was, are the variables x and y independent? The condition for us is when they are going to be independent, my f of x comma y can be written as the product of f of x and f of y. We know that this has been given to us f of x comma y. The given joint density function is x square plus xy divided by 3. And we have estimated the values for our f of x, and we know that this is going to be 2x square plus 2x divided by 3, and we just now estimated f of y also for the problem, and we have that as 1 by 3 plus y by 6. And I see that on multiplying these two quantities, nowhere I am able to arrive at the function f of x comma y. So we say that this function f of x comma y is not equal to f of x and f of y. So we conclude that the variables x and y are not independent, not independent. So they cannot act separately, they will have to depend on one another. We move on to the next quantity over here. What we need is going to be the probability of the random variable x greater than half. We'll have to keep in mind that we have only one variable defined over here. The variable defined is going to be x. If only one variable is involved, then we have only one integration. If the variable is x, then I will have to integrate with respect to f of x. And so my f of x dx is going to be the function to be integrated to find this probability dealing with the variable x. Now coming upon the limit, I want the limit of x to be greater than half. I know the total value of x is going to be between 0 to 1, and I want it to be more than half. Where is my half? Half is going to be over here, and this is going to be half and more than half. More than half is going to go over this side, and it can go to the maximum limit of 1. So my x can vary between half to 1. So now I have already estimated f of x. You need to be very, very cautious over here. Don't take the given function f of x comma y. We want only a variable x here. So take only your input as f of x. If you are going to take the two variables x and y, then you will have to integrate it twice. Now we are integrating only once. We have already completed the integration with respect to y in the estimation of fx. So I don't want the second integration with respect to y. So be cautious enough to take the input as f of x and not f of x comma y. So now this f of x, we have arrived it as 2x square plus 2 by 3 times of x. Now integrated between the limit half to 1 dx. So now we can integrate the function. 2 is a constant, x cubed divided by 3 plus 2 by 3 is a constant, x on integration is x square by 2 between the limit of 1 and half. So this 2 and 2 can be cancelled off over here. To make the work simple, I apply the upper limit minus lower limit. Upper limit is 1, 1 cube is 1, minus lower limit is half, 1 by 2, the whole cube is going to be 1 by 8. I complete the first term. Now moving on, 2 and 2 has gone. 1 by 3 is the constant. I have x square. 1 square is 1 minus 1 by 2, the whole square is going to be 1 by 4. So this makes it as 2 by 3 into 1 minus 1 by 8. 8 minus 1 makes it as 7 by 8 plus 1 by 3 times of 4 minus 1 makes it as 3 by 4. So this 3 can be cancelled off. This 8 can go off over here 2 times. So I have 7 divided by 4. 3s are 12 plus 1 divided by 4. We have already seen the trick of evaluating the fraction easily using your calculators, using the button called as A, B by C. Please use it effectively to get your answer in a rapid way. So the answer for the subdivision is going to be 10 by 12, which can further be reduced as 5 by 6. Now moving on to the next question, we want the probability of y less than half. So now again only one variable involved, so only one integration, and the variable involved is y, so I will have to have f of y dy. Now where does my y varies between? My y varies between 0 to 2, and I want the value of the value y to be less than half. Where is my half? My half is over here, say suppose, and I want the value less than half. Less than half means going this way, and so I have to integrate it between the limits 0 to half. So y varies between 0 to half f of y dy. go and estimate the function f of y is already there for us. So substitute it over here, 1 by 3 plus y by 6. Integral with respect to dy between 0 to half. And now comes the value with respect to y. This gives me y, and 1 by 6 times of y is y square by 2. And apply the lower limit and upper limit. It is going to be from 0 to half. 1 by 3 times of half minus 0, and then it goes with 1 by 6 2s are 12 into 1 by 2 the whole square, so 1 by 4 minus 0. So this makes it as 1 by 6, 2 3s are 6 plus 12 fours are, it is going to be equal to 48. Sorry, 12 to 12 fours are is equal to 48. So this value is obtained as 3 by 16 using your calculator effectively. Now moving on to the next problem, we have the conditional probability of y less than half condition x greater than half. Again, keep in mind here we need to apply the formula A condition B. It is A intersection B divided by P of B. And now to apply over here, we have probability of y less than half intersection x greater than half divided by probability of x greater than half. Now the problem is with the numerator. Now I have the probability of, I can say x greater than half, intersection is now replaced with a comma and a y less than half. Now I'll have to estimate this integration with respect to the two variables. I cannot separate them as a separate part of x separately and y separately, because we know that x and y are not independent. If they are independent, I could easily separate this as p of a intersection b is going to be p of a into p of b when it is going to be independent, if it is independent. But I know that it is not independent, so please keep in mind, don't separate this as two quantities, but rather try to evaluate what is probability of x greater than half comma y less than half. We will find this and then put it back over here. So when it comes to this is going to be the probability of two values. So you want probability of x greater than half and y less than half. So you have two variables, so which means you need two integrations and a function of x comma y with respect to dx as well as dy. Now coming to the limit of x, I know that x is going to be greater than half, so it varies between half to 1, because 0 less than x less than 1, half is over here, greater than half is from half to 1. And value for y is going to be from 0 to 2, and I want value of y less than half, half is over here, less is moving to this side, so I integrate it from 0 to half. So the function to be integrated is the two variable function, not one variable. So keep in mind, I want from 0 to half, I want it from half to 1. The function to be integrated is x square plus xy divided by 3. Once with respect to dx, because I have taken x here first, and then with respect to dy. Now let us start our integration with respect to x. X cubed by 3 plus y by 3 is a constant. X on integration is x square by 2, and the limit is 1 and half. Still I have dy to be integrated. So integral from 0 to half, apply the upper limit. 1 by 3 times of upper limit is 1 minus lower limit is 1 by 2 the whole cube, so that makes it as 1 by 8 plus y divided by 2 3s are 6 is a constant. X square upper limit is 1 minus lower limit is 1 by 2 the whole square, so it becomes 1 by 4, and still we have to integrate it with respect to dy. So this quantity gives me 0 to half. The first quantity is going to be 1 minus 1 by 8, so 8 minus 1 makes it as 7 by 8, this quantity, and when I multiply it, it is going to be 7 divided by 8 3s are 24. And now next thing to be evaluated is going to be plus y by 6, 1 minus 1 by 4, 4 minus 1 makes it as 3 by 4. So when I evaluate, this 3 can be cancelled off with this 6 for 2 times, and so I am left out with y divided by 4 2s are 8. This has to be now integrated with respect to the variable y. Let us start the integration. So this gives me 7 by 24 times of constant on integration is y, and 1 by 8 times of y on integration is y square by 2. Apply the upper limit to the lower limit, 0 to half. So we move on to the next stage. 7 by 24 times of y plus the next value is going to be y square divided by 8 2s are 16. So this is going to be 16 between the limits 0 to half. So it is 7 by 24 times of 1 by 2 plus 1 by 16 times of 1 by 2 the whole square. So that makes it as 1 by 4. So it is 7 by 48 plus 1 divided by 16 fours are 64. Take your calculator, estimate the values using your calculator, and you can get it to be 131 divided by 192, completing the last but one subdivision. No, we haven't. This is just the numerator. How to complete the last subdivision? We know that it is y less than half condition x greater than half. So it is probability of y less than half comma x greater than half divided by probability of x greater than half. We just now evaluated the value of the numerator as 31 divided by 192. And how about the denominator? Denominator also has been estimated. We know that probability of x greater than half is going to be 5 by 6. Go and substitute it over here and the problem will get over here for this subdivision. So this is 5 by 6. So it is going to be 31 by 192 into this is going to be 5 and this is going to be 6. So simplify and get the answer. So this turns out to be equal to 31 divided by 160. Now moving on to the last part of our value, the last subdivision asks us probability of x plus y to be less than or equal to 1. Again, we need to keep in our mind, fellows, that there are going to be two variables involved and we need two integrations for it. So it is integral of f of x comma y, once with respect to dx and next with respect to dy. Now the tricky part is that over here both the variables are involved and they are being connected by means of a relationship. So now quickly let us draw the region of integration and then try to fix the limits for this integration. And we know that 0 less than x less than or equal to 1, 0 less than or equal to y less than or equal to 2. When I am going to draw my axis, so this is going to be my x-axis, and this is going to be my y-axis, and then with respect to this is my x-axis. So I have my y and x. Next, moving on, I want my regions to be plotted x equal to 0, x equal to 0. The next one is x equal to 1, upper limit. Now the lower limit, y equal to 0 and y equal to 2. Y equal to 0, y equal to 2. So my boundaries are going to be, which is my x equal to 0, my y axis. This is going to be my x equal to 0. So this is my x equal to 0. Okay, so this is going to be my y equal to 0. This is going to be my y equal to 0. So this is fixed now. X equal to 0, y equal to 0. Now comes the next line, which is going to be x equal to 1. Which is my x equal to 1? This is going to be my line called as x equal to 1, which is going to be at 1 unit and parallel to my y-axis. This is going to be my line called as x equal to 1. Now coming to the line y equal to 2, where will be my line y equal to 2? So this is going to be 1 if I take, and this is going to be my line y equal to 2. It will be just one more unit in extra with the line. So this will be my line y equal to 2. Now about the given line, which is called as x plus y equal to 1, we will try to plot. What is this x plus y equal to 1? How does this line look like? This line is going to be something, when I put x as 0, I take y as 1. So 0 comma 1 is 1 point. When I put y as 0, I have x as 1. So 1 comma 0 is going to be other point. So the line x plus y equal to 1 passes through the point 0 comma 1 and 1 comma 0. Where is the point 0 comma 1? This is my point 0 comma 1. So this is not the point 0 comma 1. This is the point 1 comma 0, because x is 1 and y is going to be 0. 1 comma 0. And now about the point 0 comma 1. And where is going to be the point 0 comma 1? X equal to 0, x equal to 0 over here, and y equal to 1. I know this is y equal to 2. Y equal to 1 will be halfway through over here. So let me take this point as 1, y equal to 1. So this will be my point called as 0 comma 1. So this is my point 0 comma 1. So I have the point 0 comma 1 and 1 comma 0, and my line now passes through these 2 points. So this is going to be my line. And what is the name of this line? This line is going to be x plus y equal to 1. Now what we want is the portion less than or equal to 1. So when I want the less than or equal to 1, then which will be the region of integration? The region of integration will be this triangular portion over here. This gives me the less than part of it. So I am done with the region, now fixing the limits. Now, when I want the limit to be fixed in the direction of x, so what I do is draw a line in the direction of x-axis. So in the direction of x-axis, this is my x equal to 0. My x begins the journey with 0. And where does my y end? My y equal to 1 minus x at the ending point. So my x begins at my x will be equal to 1 minus y at the ending point. So my x begins with 0 and my x ends with 1 minus y. X begins with 0 and x ends with 1 minus y. Now how about the limit of the variable y? The second variable is going to be the constant limit because the first variable already has taken the variable limit. Now for y variation, y varies between here to here, moving in the upward direction. So this varies between 0 to 1. This is one way of considering the problem. You can also considering it by drawing a strip parallel to your y-axis, in which case what will happen over here? Draw a line which is going to be parallel to your y-axis. When I draw a line parallel to your y-axis, your y will vary between 0 to and the upper limit will be equal to 1 minus x for you. And how about the limit of x? The x value varies between 0 to your 1 over here. So this is going to be the function f of x comma y, which is x squared plus xy divided by 3. And now y has come first, so I write dy first and then integrate it with respect to dx. You can either use this way or this way. I am choosing the second method and we will see what is going to be the answer for this. So when this comes to 0 to 1, 0 to 1 minus x square plus xy by 3, this is going to be between dy and dx. So integrating with respect to y, x square y plus x by 3 is a constant, y on integration is y square by 2 between the limits 0 to 1 minus x, and still we have y varying between 0 to 1 dy, x varying between 0 to 1 dx still remaining for our integration. So we need to keep in mind the variable to be taking the value for the limit to be substituted is for the variable y. So it is x square into 1 minus x plus x divided by 2 3s are 6, and this gives me 1 minus x the whole square. Between the limit 0 to 1, let us integrate it with respect to dx. Expanded x, this is going to be x square minus x cube plus x by 6. This is going to be of the format a minus b the whole square. So it is a minus 2x plus x square. Now this has to be integrated with respect to the variable dx between the limits 0 to 1. Now let us start the integration. X square on integration gives you x cube divided by 3 minus the next term was x cube. So on integration this gives you x power 4 by 4 plus the next term was going to be 1 by 6x. So it is going to be 1 by 6 times x on integration is x square divided by 2. The previous term is minus 2 by 6 times of x square. So minus 2 by 6 times of x square is x cube by 3. And prior term is going to be plus x square into x cube by 6. So plus x cube x power 4 by 4 times of 1 by 6. Now we have to apply the limit between 0 to 1. So it is 1 by 3 minus 1 by 4 plus 1 by 6 2s are 12. And now this can be cancelled off over here 3 times, so that makes it as minus 1 by 9, and this makes it as 1 by 6 4s are 24. Use your calculator effectively and arrive at the answer 7 by 72. Hence we have completed all the subdivisions and the various kind of problems that can be asked under the case of continuous two-dimensional random variable. Thank you.